Let's go over one of the questions from paper 3, AQA A Level Chemistry. And paper 3 is all about the practical skills. So the first question from last year exam was about the senses of aspirin and how to make aspirin from 2-hydroxybenzoic acid and ethanoic anhydride. At the beginning, they provided you with the structure of the starting material, which is 2-hydroxybenzoic acid, and they ask you to give an equation for the reaction of the 2-hydroxybenzoic acid with methanol. In this case, we have an alcohol reacting with a compound that has a carboxylic acid group. So there will be a reaction between an acid and an alcohol to give you an ester. They want the product to be in the skeletal formula. So let's first draw the 2-hydroxybenzoic acid, and this is the 2-hydroxybenzoic acid, and reacted with methanol to give the methyl ester, so a reaction between the carboxylic acid group and the hydroxyl group of the alcohol. So O-methyl, and this is now in the skeletal formula. Then after that, they give you the different steps and they start to ask you about the process and the usage of the different purifying methods. So first of all, they ask you that aspirin can also be produced by a reaction between 2-hydroxybenzoic acid and ethanoyl chloride. In this experiment, we used the ethanoic anhydride. We didn't use ethanoyl chloride, but we can also use ethanoyl chloride. However, the ethanoic anhydride is preferred over ethanoyl chloride. So they're asking you why. Of course, we know that ethanoic anhydride is less corrosive than the ethanoyl chloride. Also, ethanoyl chloride will produce a lot of acid, which is hydrochloric acid, as a side product, but the ethanoyl chloride will produce weaker acid, which is the ethanoic acid. So you can write any of these. So just one of these because it's only 1 mark. So we can say that ethanoic anhydride is less corrosive. And then they want you to give the name of the mechanism for the reaction between the 2-hydroxybenzoic acid and ethanoic anhydride. This is one of the acid derivatives reacting with an alcohol or with a nucleophile. So this is going to be the addition elimination reaction. You can say also nucleophilic addition elimination or simply addition elimination reaction. When we do this reaction, we use phosphoric acid. Phosphoric acid acts as a catalyst. So they ask you to suggest the role of the concentrated phosphoric acid. It's just a catalyst. And suggest why reflux is not essential when the flask is heated to 85 degrees for 10 minutes. So in this experiment, you add the different reactants together and then simply heat them at 85 degrees for 10 minutes. You don't do reflux. We usually need reflux if the heating temperature is above the boiling points of the different reactants or products, or if we use a certain solvent. But in this case, the boiling points of all of the products and reactants are above 85. So we don't need to do reflux. So we are not scared of the evaporation of the different reactants and products. So because boiling points are above 85. So we don't need to do reflux. And then here, after they finish, they do the filtration under vacuum. So they ask you to complete and label the diagram to show to how the impure solid is filtered. Here, it's the Buckner funnel, and to complete this, first of all, don't forget the use the funnel. So this is how to draw the funnel for the Buckner funnel, and then here, this is the filter paper. And don't forget the plunge here as well. And don't forget that there is vacuum here as well, vacuum pump. So this is how to draw this correctly. And then suggest the identity of two impurities present in the filtered solid aspirin before it is washed in step 6 of this method. So before we do the washing in step 6, so in step 6 they did filtration and washing of the impure solid and then recrystallize. So what would be as impurities there? Because we have used different reactants and there are other side products. So any of these could be one of the impurities. So let's say that, for example, phosphoric acid could be one of them. So also we could have ethanoic acid, one of the side products. In addition, it could be water because we already used water in the reaction. You could also say ethanoic anhydride because we have excess of ethanoic anhydride. Some of it may still there. And also the starting material, which is the 2-hydroxybenzoic acid might be there. So any two of these would be enough. And they want you to describe the recrystallization process used to purify aspirin and include the method and the apparatus used. So we know that recrystallization, we have to dissolve the solid in the minimum amount of hot solvent, heated, and then we filter it while hot to get rid of any undissolved impurities, and then we leave it to cool to start to recrystallize, and then we filter the crystals formed by under vacuum, and finally leave it to dry. So these are the 6 steps that will give you the 6 marks. So first of all, we have to dissolve the crude product and the minimum volume of the solvent, volume of hot solvent, and then you can filter it while hot, and then you leave the filtrate to cool to crystallize, to start crystallization, and then you filter the crystals using under vacuum, and then leave it to dry, leave the solid to dry, or the residue to dry, then you will get the purified solid. And if you want to test for the purity of your product, you can use a physical properties to test for that. And we know that the property that we use is measuring the melting point. So it's measuring melting point. This is the property. So they want you also to describe 2 ways the results would show that the product is impure. We know that if it's impure, the melting point of the product will be lower than the melting point in the data book. Also, the solid will melt over a range of temperatures rather than having a sharp melting point. So also melt over a range of temperature rather than having a sharp melting point.